So my name is Matt Jordan. I'm a software developer as well for Digium. I'll be talking a little bit today about Asterisk developer tools, some of the things that Asterisk provides, some things that third parties provide, some things that you're all probably very familiar with being developers yourselves. So some things that you're actually going to have in order to do development for Asterisk, your editor of choice. I'm not going to wade into that as to what you choose to use to edit your source code. Compiler, GCC, most likely, if you manage to get something else to build Asterisk, good for you. SVN, if nothing else, to get the source code. So even if you don't actually have commit access, you'll be using SVN to at least do your checkout. But at some point in time, you're most likely going to need a lot more than just that. You're going to find that you're going to need something to help out with debugging, particularly as problems get more and more complex and as those bugs get nastier and nastier. If you start dealing with channels a lot, you'll probably be using some of the things that Asterisk provides, as well as third-party tools, things of that nature. Testing. And that could be anything from, hey, it worked on my machine, to some of the things that Asterisk now provides as well. Various test frameworks. Paul's going to talk a bunch about that later in the week. But Asterisk provides a couple different other mechanisms to help you test your changes. Reviews. We've mentioned a few times that we have review board that you can submit your reviews out to the community for further investigation and further comment. I encourage everybody to please post reviews. It's always good to get feedback before you commit something into trunk and then find out that you broke ChanSIP. And also, we also provide various tools to help you safely commit and merge code. So if you're fixing a bug, you may actually be given permission to merge it back into 1.8 or 10 if it is a bug that is in that version, because those are still both supported releases, obviously. 10's not even quite out yet. So what are some of the things that Asterisk provides for debugging? You've got, of course, various ways of dumping information out to the CLI console or to logs. We've got AST log, so make judicious use of that, particularly for errors and warnings that should always be sent out. If you assume that this structure pointer should never be null and you get it and it's null, please do send an error, right? Because something bad is about to happen. That's good to log that kind of thing. But for your own actual debugging, you also have ASD verbose, which can be seen typically sometimes by users. The trainers will tell users sometimes to start Asterisk in verbose mode, so if there's information you want to pass on to other people without them necessarily being developers, you can use the ASD verb calls. Or if it's just you, and that's sort of the only caveat we have for AST debug is it's for developers. It's information for developers. So if you're trying to figure out or trace something down, or if it's helping you to develop things, you can always use the AST debug calls to send information out to the log files and things of that nature. In general, in a production system, you would never want to turn on debug. It'll slow things down. A new call that was added fairly recently is also ASD Back Trace. That's got some usefulness because what that'll do, you can put that anywhere in the code and it'll automatically generate a backtrace at that point and send it off to the debug logs. So if you're wondering what's calling my code and how many different stacks am I down in and what thread's on it and everything else, that'll help you find out what's going on. And of course GDB. Has anybody in the room not used GDB at some point in time? Few people. All right, so command line debugger lets you do a couple different things. You can attach to an existing process to see what's gone wrong. You can generate back traces by attaching to an existing process. You might be able to set breakpoints. Your mileage may vary depending upon how well GDB is playing nice with you at that point. You can run a process through GDB. You can set back traces. You can set breakpoints in there to step through your code. You can also analyze core dumps in case Asterisk does crash. Asterisk never crashes, of course, but If Asterisk crashed and you got a core dump, you can also use GDB to analyze that, and a lot of times that's something Life or Paul will ask you to do if you get a core dump, to generate a backtrace and attach that to the issue tracker. And there's also UIs available for GDB. If you're not a command line guy, there's DDD. There's some of the IDEs on Linux support some UI abstractions over GDB. And, most horrific picture I could find of a bug. This is all sort of to prevent this guy from landing on your desk or on the desk of somebody else. And Asterisk also provides you a couple tools as well built into it, into the CLI, to try to help you find problems before they happen or help you analyze problems when they do happen. So has anybody ever had a deadlock in Asterisk? All right, so here's a couple scoffs. So deadlocks are something we go after as much as possible, but because of the complexity of some of the nature of Asterisk, it does sometimes happen. And sometimes you'll get things that look like a deadlock, even when they're not, right? There was a bunch of problems with some of the timing sources that happened in a couple versions back. I don't know if any of y'all have been watching the Asterisk dev list. And there were a bunch of things waiting for a timing source to come back, and it just never came back. Well, it's not exactly circular waiting, but it's close. But so core show locks is a CLI command that'll actually show you the threads and the locks that they currently hold. So you can try to determine if you've got a circular waiting condition between various threads to see if you've got a deadlock. On that same vein, you've also got core show threads, which shows you all the threads currently executing in Asterisk. Tell you if you've got orphan threads, and gives you a snapshot of what's currently going on in the system at that point in time. There's a couple other various flags that you can enable. These two are both enabled through make menu select, which is a little utility that'll let you turn on these flags and recompile Asterisk with this functionality enabled. There's other ones that you would actually possibly have to go into the source code, but you can get pretty heavy with it. We can actually trace memory allocations. We can trace reference counting on objects. So all those various things, if you actually are using ref counted objects or you have memory leaks going crazy and Valgrind's not helping you, you can turn on additional flags to give you more input as to what's going on. So, and we'll see how well this goes, but we're going to actually try to make a deadlock. Let's see. All right, so there goes Asterisk. All right, thanks everybody. So this is a version of Asterisk in which we purposely introduced a situation where chan local should stomp all over itself and hopefully deadlock on me. So first thing I'm going to do is just do a core show locks. And hey, nothing's locked. Now, I might get unlucky and maybe the logger is writing and it holds a lock. So just because you see something here, that doesn't mean anything bad necessarily is happening. Threads do things. Sometimes threads hold locks. That's okay. But, you know, right now when I took a snapshot of the system, there's no threads currently holding locks. And you can see that it tells me some various information about what it's going to dump out here. The name of the lock address, the number of times it's been locked, where it was locked. So it gives you a lot of information in terms of tracing things down. So let's see. I'm going to set this down for just a second. Oh, thank you. So yeah, my laptop here isn't showing me what I'm typing. All right, so this is doing some things. And it kind of looks like it finished. Maybe. It didn't deadlock. Let's try that again. Yay, it deadlocked. So this is what you'll see sometimes when you have a deadlock. And really what we would want to look at here is we'd look for a situation of a circular dependency between the threads. It's a little hard to show, obviously, because I've got microfiche up here, and it's a little hard to see. But really what you'll look for, you can see here, it's actually showing all the locks held by a particular thread. And it says here that I'm waiting for the lock number 2. And lock number 2, it happens to be P, and this is the address of it. And in this case, the address is F490CC8. So if we go browsing through this, we can actually see all the threads that own that lock. So we'd look to see the thread that has that lock. So let's see if I can't find it. Although this might be a little hard to do with. So that was F4C. I'm still on the same. Let's see. A little bit higher up. There he is. So you can actually see him right here. So this thread actually is holding that lock right now, and he's waiting for a lock, which happens to be F4FF2B8. And if I scroll down, I would find that as well, because we could try for this example. So in this particular case, we introduced a deadlock. Asterisk is now going to wait infinitely for that to come back. So I could actually even do things like I could actually look for the threads and do other types of interesting information to gather more information to try to figure out what's going on. And one of the things this also tells you is that in this particular case, it's waiting for a lock held in method awesome locking in Chan local, and that actually is a real method. And we inverted the locking order in there, so that actually is where we introduced this deadlock. So a lot of times this information in core show locks will help you find the initial points to start looking for what went wrong. So there's a very good debugging tool if you actually find yourself in this horrific scenario, which is sort of, you know, the 10-pound bug sitting on your desk. Thank you. Okay, some other third-party tools that are also very useful for debugging issues and helping out with coding in Asterisk. Has anybody not used Wireshark? Anybody not want to admit to not using Wireshark? Okay, so I won't show. I actually have a little demo of Wireshark, but since this is kind of challenging to guess when I'm hitting on my buttons, I won't go through it. I can show you after the demo if you'd like to. If you don't want to admit that you've never seen Wireshark, I can walk you through some Wireshark examples of showing SIP traffic. But Wireshark's a great tool because it's a packet sniffer. So if you have issues with SIP and you're not sure, or EEX, or many of the other telephony protocols, it actually has analyzers that will show you your SIP traffic or your EEX2 traffic or whatever you've got. So if you say, wow, for whatever reason, I didn't get back a response from Asterisk from this phone that I expected to get back, why isn't Asterisk giving me back? You can actually put Wireshark on your network, pull down your packets, see what Asterisk is actually sending, look at the call flow, and possibly attach that information to a Jira issue tracker. Not that I'm plugging, giving us more information, but I am. So Wireshark is fantastic for that type of thing. Valgrind is another very useful tool that I would actually encourage everybody to run. If you're going to commit code to Asterisk, run your patch under Valgrind. Valgrind helps detect memory leaks. It does a lot of other types of things in terms of invalid memory accesses. And Asterisk actually comes included with it a Valgrind suppression file to try to hide all of the things that Valgrind might flag that we don't care about too much. That actually is in contrib/valgrind.sup. And if you go to the Asterisk wiki, there's actually a walkthrough on running Asterisk under Valgrind and dumping information out. So that's a huge benefit for everybody because memory leaks affects everybody over time. Right. So there's also some other build options that you can use to help with Valgrind. Those are also done through make menu select, that little utility that helps you turn on additional compiler flags. malloc debug, dot optimize, and debug threads are three that we recommend putting on if you're going to run under Valgrind. I'm just clicking everywhere. Okay, so that's debugging. Now we get into unit testing, or testing, right? So why unit testing? What is unit testing, and why do you care about it? Well, say, for example, you change some parsing in SIP. A lot of people's mechanisms for testing that would be to get a bunch of phones out and just keep calling Asterisk and hope that it works. Or see, hey, I did 50 calls and it didn't break. That's not bad. That's okay. But at the same time, there might be better ways to test. So in recent editions of Asterisk, we included a unit test framework. And what that actually lets you do is, within Asterisk, exercise portions of the code. So you can actually write a unit test that just tests your parser or whatever you changed. And within Asterisk, it'll just execute that method, and you can actually specify your test conditions. You know, yay, make sure that if I pass it a null pointer, it doesn't crash. Make sure that if the SIP packet doesn't contain this format specifier, that I handle that correctly. And so you can just exercise whatever you've written, and then it actually gets put into Asterisk, and we'll actually exercise it every time a commit goes in, because that actually is executed by the test suite every time somebody does a commit. So it helps keep the code base robust and mature, and gives you a better feeling that the code change that you're putting in is actually going to do what you hope it does. You enable that again by turning on some additional compiler flags, by running configure enable dev mode, and then enabling the test framework flag through menu select. There's various commands on the CLI in order to execute the tests. You can do a test show registered, which will show you various tests and categories and names as to what tests are currently put into Asterisk. Test execute, which does exactly what it sounds like. These are very self-explanatory, so I probably don't need to say them. But you can also save off your results. So if you have a test that fails, you can save that result off and say, hey, I made a code change and look, it broke this other test. Digium or somebody on the Asterisk dev list, what's going on with this? And you can put your result file out there. And there's some good examples actually already included in Asterisk for developing a test. For a unit test, there's testscale.c, which gives you the basic framework for writing a unit test. Okay, so I believe Paul or Life mentioned it briefly, but we have a project called Repo Tools, which provides a collection of tools that are useful for developing for Asterisk, things that actually help you do SVN merges, things that help you do post reviews out to review board. So if you download Repo Tools and do the installation, which is if you go again to the wiki, there's a walkthrough on actually installing and setting up Repo Tools. One of the tools on there is called post review, and this will automatically send an SVN diff to review board. So if you make your code change and you want to send it up to the community in order to get some feedback on it, you can do post review and off it goes. I was going to walk through that, but again, I think I'd probably type it in wrong a whole lot. But I can show you that after the talk if you'd like. And I would actually again encourage everybody. It's always okay to post a review. Do look through your code change before you send it out to the community. Otherwise, you might get some feedback that says this isn't ready. But do solicit feedback from the community on your patches and things that you want. We do have a very healthy community, and we do try to look at everything that gets put up on review board. Finally, some of the other development tools that are included with Repo Tools are things that help you merge your changes into the various branches in Asterisk. So rather than actually, if you develop a patch for a bug for 1.8, you don't have to redo that 3 times. You don't have to rewrite it again for 10, rewrite it again for trunk. There are tools that will help you merge your change from 1.8 up to 10 safely. It'll tell you if it fails and tells you where it fails. And then you can fix that, do your commit, then merge from 10 to trunk. And so it just keeps going through all the branches and helps you get all of your patch put up into all the various branches. So if you find yourself not just doing new features, but also doing bug fixes of that nature, those things in Repo Tools help you out, keep you moving forward as opposed to doing the same thing over and over again. There's also some things in Repo Tools and also up on our SVN server that help you keep, if you have your own private development branch, up to date with what's going on in trunk. You can set up auto merge and be notified automatically by email if there's any conflicts. So if you're working on some nifty patch to Chan SIP on a private branch, on a private developer branch, you can set it up so that everything that goes into trunk also automatically goes into your development branch. And if somebody else does a change to Chan SIP and it conflicts with yours, you'll get an email saying that you got a conflict. So then you can go out and resolve it and automatically keep yourself up to date. That's really useful if you're doing a long-term change. If your change is going to take more than a couple weeks, somebody else has a good chance of submitting something that changes some code that you're currently working on. So that when you post your review up, you might get a comment that says, wow, this looks really old. You're missing all these changes. Now you have to manually go back and do that. So this helps keep you up to date with what's going on in Asterisk all the time. And so lastly, Life had mentioned it, all of the information pretty much in these slides is actually on our wiki. There's a bunch of small articles for developing an Asterisk. I would encourage everybody to go look at the wiki, read it up. If you have comments or you think that things need improvement, please feel free to leave a comment or add your own contributions once you get right access by contacting Life. So, questions?